Hey everyone, and welcome to today's deep dive. We're diving into the world of AI and software, specifically how large language models, or LLMs, and LLM-based agents are transforming software development.
It's incredible to think that we now have AI systems that can write and understand code, often surpassing human capabilities.
It's like having an army of superpowered programmers, right? And what's fascinating is that this technology isn't just for the tech elite. It has implications for every piece of software out there, from the apps on our phones to the systems that power entire industries.
Absolutely. And to really appreciate how revolutionary this is, we need to look back at the history of LLMs and their connection to natural language processing, or NLP. Hold on. So this whole LLM thing, it's not some brand new invention. Not at all. The roots of LLMs go back decades. Early attempts at NLP, like rule-based systems for basic conversations, date back to the 1950s.
Wow, the 50s. That's amazing.
It is. Then the 80s and 90s brought about major breakthroughs with machine learning and neural networks, really propelling NLP forward, especially in areas like automated text translation.
Okay, so we went from translating languages to AI writing code. That seems like a huge leap.
It was, and that leap was largely due to the Transformer framework introduced by Google in 2017. Transformers revolutionized how we process language, enabling parallel processing and making everything significantly faster.
And that's where OpenAI's GPT comes in, right?
Exactly. OpenAI took that transformer technology and created GPT, which stands for Generative Pre-trained Transformer. Their first model came out in 2018 and was groundbreaking in its ability to understand and generate human-like text.
I remember when GPT-3 was released, everyone was blown away by how realistic and creative it seemed.
Rightfully so. GPT-3 was a significant step forward, but OpenAI didn't stop there. In 2023, they released GPT-4. While similar in size to GPT-3, it was even better at handling complex tasks and generating different creative text formats like poems, code, scripts, even musical pieces.
So we have these incredibly powerful LLMs that can understand and generate human-like text, including code. But how does that actually work in the context of programming?
At the core of it all are two main architectures: encoder-decoder and decoder-only. The encoder-decoder model works like a translator. It takes code written in one programming language and converts it into another. Codify Plus is a great example of this architecture, and it's known for its deep understanding of code.
So encoder-decoder is all about translation. What about the decoder-only models?
Decoder-only models are like master craftspeople. They generate something new from scratch. Think of it like giving a skilled writer a prompt. They use their knowledge to craft a story. Decoder-only models work similarly with code. They take instructions and generate code based on those instructions and their training data. GPT-4, for example, excels in this area.
So we've got